Welcome back, Calculus. We are going to be looking at a review of limits. So hopefully a lot of this is a review from Precalc. If this is not feeling as smooth as you would like for it to, I'm going to go ahead and post another video that will go a little bit more in depth if you do need that additional review. Okay, for now I'm going to pause your screen to make sure that you've got everything on the checklist ready to go. Alright, so limits are really the very first topic of calculus, and the way we read this statement here is the limit as x approaches c of f of x is equal to L. Okay? Now the following needs to be true for the limit to exist, so I'd like for you to write this with me in your notes, please. We need the limit as x approaches c from the left, and the way we're going to denote that left-hand side is by a little negative, I should say a superscript of a minus, okay, of f of x needs to be the same, so it needs to be equal to the limit, so I'm going to go lim, and underneath as x approaches c from the right, and the way we're going to denote coming from the right is with a little superscript of a plus of f of x, okay, so let's mark those in our notes. So just a little note for ourselves. This is what we call the left-hand limit. And that's what we call the right-hand limit. All right. And if you remember from Precalc, this is what needs to be true in order for the limit to exist. That what I'm approaching from, I should do it this way, from the left is going to be the same as what I'm approaching from the right. Okay, we do not have to actually reach that point, but we have to be approaching the same value coming from the left and the right. Okay. Okay, so there are three ways to evaluate limits. We've got graphically, which is what we're going to spend the next couple days on, numerically with a table, and then algebraically. Okay? All right, so from Precalc, can you look at these two graphs? Is there anywhere where the limit does not exist? Okay, for both of these, the limit exists everywhere, okay? Because remember, if I draw my little vertical guide there, no matter where I draw it, coming from the left and the right, I'm going to approach the same y value. Alrighty? Now, the only maybe question mark here is what about that open circle there on the second one, on the parabola at 2, 3? Okay, well, if I draw my guide here and I approach that vertical line from the left, so I'm going to make a little circle there. And as I approach that guide from the left, what y value are we approaching here? We're approaching the y value of 3, right? And if I try the same thing coming from the right-hand side, so if I grab onto the function somewhere to the right of that wall and start approaching that guide, come closer and closer again to that y value of 3. Right? So how do we write this? Well, we say that the limit as, what is x approaching? Where did I draw that vertical line? That's x approaching 2, right? We'll assume this is f of x, is equal to, and what y value did we approach from both sides? 3. Alrighty. Alright, so let's try a problem. I'm not going to put a prompt on the screen because the prompt is going to block the whole screen, but do me a favor and just pause the video right now and copy both the graph and all the questions for me. Okay, so let's try these together. So if you'll notice here, it looks like all my x's are, we're looking at what's going on around x equals 2. Okay, so let's go to our graph and draw a little guide, a vertical line at x equals 2, okay? So that first one asks us to approach that line that we just drew, coming from, see if that'll go away, coming from the left-hand side, okay? So I'm going to grab onto the function somewhere to the left of that guide that I drew, and let's approach that guide coming from the left. So what y values are we approaching there? And we're on -1 the whole time, right? So the limit as x approaches 2 from the left of f of x will be -1. All right, the next one asks us to find the limit as x approaches 2 again, but this time coming from the right-hand side, right? So let's grab onto the function somewhere to the right of that guide, and now let's approach that guide coming from the right-hand side. Can you tell what y value am I approaching? So I'm approaching y equals 1, right? Do I land there? No, but it's not what happens right at 2, it's what's happening around x equals 2. So as x approaches 2 from the right-hand side, in other words, as we use values greater than 2, my y values are approaching 1. Okay, now what would you say the full limit is? So in this case, the full limit does not exist. Why? Well, if you go back to that definition that we wrote, for the full limit to exist, the left and the right hand limits have to be the same, right? But we got two different values for our left and our right hand limits. So since those are different, the full limit doesn't exist. Now, let me ask you this. What do you think the most common incorrect answer is for this one? The most common incorrect answer is -1, because people go to that closed circle right there and they say that's the full limit. Remember, the full limit has nothing to do with an open or closed circle. It's what are you approaching, and we have to approach the same y value coming from both the left and the right. Now, what does that closed circle represent? That closed circle represents what happens exactly at x equals 2. So that's my next question. What is f of 2? So in that case, you're going to the closed circle. F of 2 is -1. Okay. All right, so now let's try those two on the bottom left. So now it says, what's the limit as x approaches -infinity and positive infinity? So when you've got these, you're not going to draw that vertical guide. You're going to think about which way am I moving to infinity. So it's, first of all, x, which is going to be your horizontal, right? So if x is going to -infinity, we'd be going to the left. Oh, I'm doing it the wrong way for you. The left, okay? So as I go to the left forever, that is going to be that way, right? So as x's go to -infinity, do your y's approach any single number? Now it looks like my y's are continually on -1, okay? So the limit as x approaches infinity here is -1. All right, what about x approaching positive infinity? So that would be going to the right forever. So as the graph goes to the right forever, what happens to the y values there? They go up forever, right? So in this case, the limit is positive infinity, which, by the way, infinity is not a number, right? So another way to say this is the limit does not exist, D&E. All right, let's kind of piggyback off that. Again, would you go ahead and pause your screen? I'm not going to prompt you because it's going to cover the screen, but go ahead and pause the screen and copy my screen. All right, so let's try these limits. Let's again look here. So it looks like all my x's are approaching 0. So let's draw that guide at x equals 0, which would be the y-axis. All right, we want to approach from the left-hand side. So I'm going to grab onto the function somewhere to the left. As I approach that vertical guide that we drew from the left, my y values are going up forever, right? So there's two ways to write this. You can say that the limit is positive infinity, but once again, positive infinity is not a number, so it is fine to say does not exist. I would accept either answer. Okay, now let's try the same thing coming from the right-hand side. So I'm going to grab onto the function somewhere to the right of that guide. And as I start approaching that guide from the right-hand side, my y's just keep going down, right? So my y's go down to -infinity. Again, that is not a number, so it's fine to say does not exist. Okay, now for the full limit, you only have one option because you did not get even the same kind of infinity for the left and the right hand limits, correct? So for the full limit, that's a does not exist. All right, so basically we got some vertical asymptotes there, right? Because my limits were either positive infinity or negative infinity. So you see those created a vertical asymptote. Now let's talk about horizontal asymptotes as limits. So take a look at the bottom two questions there. This time we want to know what happens as x approaches negative infinity or positive infinity. So no longer are we going to draw some kind of vertical guide because now x isn't approaching a number. It's going to the left forever or to the right forever, respectively. Okay? So as we go to the left forever, that would be this direction. Do the y's approach anything in particular? Yes, the y's approach 0, right? And as we go to the right forever, that would be as x is going to positive infinity. Again, the y values are approaching 0. So remember, it's what y's are we approaching? Okay. All right, so we've talked a little bit about when do limits fail to exist. Another instance limits fail to exist, and it's a pretty interesting case, though it doesn't pop up a whole lot, is when your graph just oscillates back and forth and never actually lands on a particular number. And kind of the classic example of this is sine of 1 over x. You don't need to write it in your notes, just kind of an interesting FYI. All right, so again, do me a favor, pause your screen, copy my screen, and then we'll work all these together. Okay, so it says, find the limits and function values for each discontinuity, which a discontinuity in layman's terms is when you have to pick up your pencil. So which means we pick up our pen or pencil when we draw this graph and identify as removable, jump, or infinite. So hopefully those words kind of sound familiar from Precalc, but we'll go over all those, okay? So let's first go ahead and try these limits and function values. So now that you've got it all written down, I'm going to force a pause on your screen and try these on your own. All right, so answers are on the screen. You can check yourself, pause if you need to. Remember that a limit is what we're approaching, the y value we're approaching, and it has to be approaching from the same side unless you're approaching, plus or minus as x approaches plus or minus infinity. Function value is what y value are we on exactly at that exact x value, okay? All right, now let's talk about, in the second part of this question, it asked us to identify each discontinuity. So first think about how many places, how many x values do I need to pick up my pencil if I were to draw this. So I'm kind of sketch over this. I need to pick up my pencil at -5, right? And I keep going. I would need to pick up my pencil again at x equals -3, and then again at x equals 1, okay? So let's label these. So this guy here, which one do you think that is? So that is actually going to be a removable, because it's just 1 point removed from being continuous, right? If I move that point down, I have a continuous graph, okay? All right, this next one here, kind of this infinite, this asymptote, that is going to be your infinite discontinuity, okay? And then your last kind of discontinuity is a jump, and that is this piece here. So you've got a break, your left and your right hand limits both exist, but they're different from each other, so it creates kind of this jump. Okay? So we mathematicians are typically not super creative with our vocabulary. The nice thing is that typically what it sounds like is what we're describing. Okay, so let's write some closing statements here. Will you write this with me in your notes, please? Closed circles affect what, not what. What do you think? Yeah, so closed circles affect function values, not limits, right? So don't ever think, oh, there's a closed circle there that affects the limit. Nope, that is just talking about the function value. Okay, now what about horizontal asymptotes versus vertical asymptotes? So here's a look at a horizontal asymptote, right? So for a horizontal asymptote, x is not approaching a certain number, right? X is either approaching negative infinity or positive infinity. So horizontal asymptote, would you write this please, would be the limit as x approaches negative infinity of f of x, or the limit as x approaches positive infinity of f of x. Now for a vertical asymptote, that would be something like this guy, right? That's where your y values are approaching plus or minus infinity. So we would write that as the limit as x approaches whatever number. In this particular graph, it's -3, right? But I'm going to write c for some constant. So the limit as x approaches c of f of x would be either infinity or negative infinity. Okay, so make sure you really kind of keep those straight in your mind, the difference between horizontal and vertical asymptotes in terms of how we write them as limits. Okay. All right, so don't forget in your assignment to type in any questions or comments. Again, it's always fine to have no questions or comments. Just write NA, and then also it's always fine to write something if you have any non-math questions or comments. All right, good job, you all. Thank you.